Next one is an archive paper that's a little bit old, but I wanted to put this as a reference. This was neat because it was this idea of a 1,000,000-step task, getting a 1,000,000 steps done with LLMs. And why this is interesting research is because of this whole context rot problem. That if you just gave a LLM 1,000,000 instructions in one giant markdown file, even if you get it into its context, somewhere along the way, it's going to go off the deep end and do something you didn't want it to do, make you a React app or something. And you're not going to want that. So what are the ways that we can constrain these systems to do what they want? This one is a system called Maker, which solves a task with 1,000,000 steps and 0 errors. I want to just point out this. The approach relies on extreme decomposition of a task into subtasks, each of which can be tackled by focused micro agents. High-level modularity resulting from the decomposition allows error correction to be applied at each step through an efficient multi-agent voting scheme. So I think that's the important with any type of management, whether it's human or AI. And, like, I don't know if anyone, you've ever worked, in like a fast food kitchen, right? They have a very defined process, and you don't need to think about the farm where the meat grew, and you don't need to think about the, how it gets consumed. You have to focus on exactly what you're doing at that one point. Patty off the grill, onto the thing, wrap it up, next, right? And if you could break up that part, break it up into a series of steps that you can then verify the output, that gives you that reliability, rather than just saying, here's a 1,000,000 step process, go and do it, and depend on the token, the attention mechanism to kind of work. What are your thoughts on that?
I remember coming across this, and I admit to not having read the paper and having only read the abstract. I did see that the Towers of Hanoi benchmark was mentioned there, and I don't know if people are familiar with that. I think that's the thing where you have a bunch of pegs and you have to move rings from one to another and a combination of things. And so maybe a very specific kind of challenge, and I'm not intimately familiar with the mathematical foundation of that puzzle and how that could be decomposed into tasks. I think that's going to be interesting to take a look at. The first thing that I thought when I read it was like, oh, this is a pretty narrow domain that they're measuring things on. But I don't know. There could be something for me to learn from, for sure. One thing that is definitely interesting through this is the decomposition itself is a huge challenge. And I'm working on developing a new spec-driven development benchmark, because we did. We'll get to the end, we'll talk about the death of sweep bench verified. But it's interesting to see, like, okay, what is the deliverable that you give to an agent harness? Is a general spec in the form of a PRD and like, this is what I want? Or is it to the level of a list of tasks with dependencies and acceptance criteria? Because that is a huge difference. And the ability for autonomous, long horizon agentic work, it depends on that decomposition. And it depends on the verifiability of each atomic task.
One of the cool things that Gastown does, Gastown is one of the very popular agent orchestration frameworks. It has this underlying thing called beads, which it bills as an AI-first dependency management ticketing system. And when you talk to the kind of the head agent of Gastown, it makes a set of beads, and each bead is in to know kind of how to pick up a task and end it. And you don't have to know the whole context of everything. And the idea of Gastown is that it will dispatch these beads to these agents who clone a repository at a certain step, make some progress on this, and then report it back. And so I think what you said really importantly is, if the LLM or the harness knows how to check if it did it right, then that's what really helps them. And that's why compiled languages like Rust have that advantage, because you can check, did I get this right? Just the did it compile test is a good test. I think with Towers of Hanoi, it's very much like, how do you say it? Like, there's a process, and it's very, very, on one hand, it's easy, but the taller the towers get, the more backtracking you have to do in this process, because you have to stack these rings, and you can't have a bigger ring on top of a smaller one And so you have to think, okay, I have to swap this one here, move this one here, and then move it back. And the more of a move you need to do, the more planning you need to do for backtracking. And so that's where it's a neat metric. But I think, this is going to be part of project management, whether it's with AIs or with people, is breaking it down into verifiable tasks. What did you think about that clip? I hope it was useful. Check out the link in the description for the full episode. And we have new episodes coming out every single week, sometimes several times a week, about the latest AI news. We're doing a deep dive into OpenClaw soon. Check out our Substack. Follow us on all the different social media programs. Ask us questions, and check out our Discord, where we have lots of good AI chat discussions. Links are all in the description. See you next time.